There's one minor pointer related thing we should get to now, because in the next topic we'll have, which is actually after midterm 2, we'll need this. And it has to do with pointers that don't point at anything. I know that's a strange thing to say, but it does actually come up a lot in practice. So here's an example. On line 17, I'm creating a pointer called P. And as the comment points out, there isn't anything for it to point to because I don't have any other variables. P is supposed to be an int star. There are no ints. So the first thing is, what does P point to right now? On line 17, what is the value of P? And remember that P is a regular variable. The rules for pointers are no different than the rules for ints or floats when we create them. If I don't give P a value, it is undefined. So what does P point to? Well, we don't know. It could point to anything. It just points off into the distance. And we should understand that if we were ever to follow this arrow, bad stuff could happen. Because if we follow the arrow to nowhere in particular, what does the arrow point to? It could point to something important that we don't want to modify. It could point 200 kilometers offshore. We don't know. And so, of course, just like any other variable, we should never use a pointer if it's uninitialized. But then the question is, wait a minute, I want to initialize the pointer, but there's nothing for it to point to. And also, there could be times when I create a pointer, but I don't have anything for it to point to just yet. So what do I do? And it turns out we have an answer for that. There's a special value in C that you can assign to any pointer. And it is, as a convention, adopted to mean the pointer doesn't point to anything. And it's this value in all caps, null. Now, one thing, the very first thing to understand about null is that it's not magic. You can't just use null as a surrogate for nothing in every context. It can only be applied to pointers. You can't use null as an int or a float. Null is only applicable to pointers. And in particular, what null really is it's actually a pointer that's designed to never point to a valid location. So what I like to do in my diagram, there's a few ways of representing it. So there's P. Sometimes people on diagrams represent the value null using this symbol, which is the symbol you would see on a circuit diagram for going to ground. The problem is we don't necessarily know too much about circuitry, nor do we want to in a course like this, so I like using this notation here. It's an arrow that just sort of points like this. And if I use this, it means that the variable P points to nothing. It contains the value null. Now, again, null is just another memory location. It's actually an arrow pointing at an actual place, but it's a place that's guaranteed to never be valid. Your program will never, ever have a variable at this location. So you can use this as a sentinel, as a signal that the pointer doesn't point to anything. And it's often used that way. We'll see in our next topic after midterm 2 that there are functions we work with that return pointers. And in cases where those functions have nothing to send us, they'll send us the value null as a way to tell us that they had nothing to give us. And the value null is for a pointer that points at nothing, and it is considered to be an error. And the error will be very obvious because the program will crash. It is considered to be an error to ever attempt to follow this arrow, to nothing. If you do that, the program will crash. You'll get one of those segmentation faults. Okay, so what else do we have to know about null? Well, the main thing is if a pointer is set to null, it points to nothing. And it can be assigned to any pointer type, int star, float star, char star, star, whatever. Any pointer type at all can have the value null. And importantly, you can use if statements to test whether a pointer is set to null. So I guess I'm going to draw out the rest of this diagram here. So I now have a variable called x, and it's an int. And I've got this variable down here, a new pointer I create called q, which is set to contain an arrow pointing at x, and x is set to 6. So the first thing I do is I ask if p is not equal to null. If p is not equal to null, I'm going to print p is valid. But of course, p is equal to null, so I'm going to print instead that p is invalid. I can also test q, and we'll see that it'll print q is valid, or q is, whoops, I shouldn't have done that. Q is valid, it is not equal to null. Otherwise, of course, Q is invalid. And remember that if a pointer is equal to null, you can never follow the arrow. You can never write star Q if Q contains the null value. It's worth considering because we know already that inside an if statement, we don't actually have to use a comparison. We know already that it would be valid to write weird things like if 10 or something like that because of the way that true and false is interpreted in C. And it turns out pointers have a similar interpretation. The value null is always interpreted to mean false. And that means you can ask whether something is null by just putting if p. If p, well, that's saying that if the value of p is not equal to null, effectively. And so that means if this if statement is true, p is valid. And so a very common way of testing whether a pointer is null is just writing if not p, which is a bit of an acquired taste. But it turns out if you write a lot of C code, you will begin doing this very quickly. It is actually quite convenient, and I read a lot of code that uses this. It's a strange thing to see at first, but it is a very common idiom to see. And the idea is that because the null value is always interpreted to mean false, and a pointer to anything else is always interpreted to be true, you could just use the pointer directly as the condition in the if statement instead of having to ask explicitly, does it equal null or not? That said, I think this is still a nice way of writing it. It makes it much more obvious what you're doing, and it's much more clear to somebody reading it that you're working with pointers at that step. Now I'm going to quickly run this, and that's all we need to know about null for now, because we'll see once we begin working with things like files that we have other uses for it. But other than that, we just need to know that there is this value we can use to explicitly indicate that a pointer points to nothing.